Hey guys, I thought I'd just give you a little run through about a microscope, just to refresh that memory and have a little bit of retrieval there, so we can remember how we set up a microscope, how it works, microscope slides, how we produce a slide for a microscope, and what it's all about. So we can start off with the eyepiece. If you look here, we've got the eyepiece, and that eyepiece is reading 10 times there, 10 times magnification. That 10 times magnification is going to start there in that eyepiece. It's where we put our eye to have a look, and that's where we look down into the next part. Or the arm is holding this part up, so we don't forget the arm, don't neglect it. It's important, but really what is important are these objective lenses. As you turn them, they'll click. You'll feel them click into place. There it is, click, click, and click. And these objective lenses have different numbers on them, again, different magnifications. So I want the widest field of view. I want to be using this smaller objective lens, which is a 4 times zoom. So I'll click into the 4 times zoom, so I know I'm at my widest field of view, so that I can see as much of the slide as possible. We have our stage clips. They're very important. They hold the slide in place. We've got our stage. That stage is going to be moved up and down using these adjustment knobs. There we go. We can see it going up and down and up and down. Now we need to be careful when we go upwards. We always start a little bit higher and move weight downwards, because if we don't, we could crack the slide up against the objective lens. That normally isn't an issue when you're on the smallest objective lens, the most widest field of view, because it's short. But when you get onto the longer ones, you do get close to the slide, and you don't want to be cracking that. So I'd start up higher and move my way down. I'd also need a light source, and our light source comes down at the bottom here. It's in the form of a mirror on this one. Some of them have a light themselves, and often what we do is we shine a light onto this mirror and angle it up so it comes through there. And that is so that we can lighten up the slide so we can see it through here. Okay? Hi, so I'm going to talk to you about now how you prepare a slide, just so you know what's going on. I haven't got it really in front of me because I haven't got the necessary materials at the moment, but I'll talk you through it and show you, if I can, through images to support that. So first of all, I would take my slide, my blank slide, check that it was clean, make sure everything was good, and I'd have that ready for my sample to go on. Now if I was using a sample such as an onion, I would use an onion cell. I'd want to see an onion cell. That would be a plant cell. I'd want to see that on the microscope. I would stain that with iodine. We'd use the iodine to stain a plant cell. If we were using a cheek cell, such as the one in our mouth, we could use methylene blue. That would show that animal cell up. They're very sparse. They're not as structured, because you're swabbing them out of your mouth. You're not actually cutting them out of your mouth, which is a good thing, I suppose. And then what we do is we get our slide, and we find that we do have to use a knife. We have to slice up that onion and find out one sheet of onion to put onto our slide. And once we get there and put that onto our slide, it should be 1 cell thick. It's got to be flattened out. So we use a cover slip. So once we've stained it with the iodine, we then use a cover slip, and the cover slip then goes over the top of that sample. That'll flatten it for us. That'll push out all the iodine, and then we're really ready. We mustn't forget, when we're using the iodine, you know, and the methylene blue, they are dangerous chemicals. We should be using or wearing our goggles for that, and make sure that safety is the priority. Once it's covered by the cover slip, you're going to have to take your goggles off to look through the eyepiece, but we get it onto the stage and under the clips to hold it in place, and then that's why we're on our smallest objective lens, so we get the widest field of view, so we can have a look in here and see what it is. Then we'd focus away from the slide until it becomes clearer, the image becomes clearer. Remember, we're focusing so the image becomes clearer, and we're zooming to magnify that image. So they're two very different words. Magnification is very different from focusing. Do remember that, that's quite important. And yeah, that would be your sample. What I would do with that sample is I would take that, I would look inside here, and I would then do a drawing of that, and I'll show you an image now, just so you can see what that would look like. and that would have a sample of cells across it. Look a bit like a brick wall, I suppose you could say that, or a honeycomb, and that would be great. Feel free to draw a diagram, see what you can remember from what I've talked about, and have a go at labelling it. Then press pause and use this diagram to support your answers. See how many you got right, see what you did get right, and test yourself. So we can see here from this table that if you wanted to calculate the total magnification seen through the microscope, you would times your eyepiece by your objective lens, and that would get your total magnification. And you can see the three lenses differentiated by red, yellow and blue. And Robert Hooke founded this. He looked at cork under a microscope, and a very different microscope to what we have today. And he founded this and decided that he would look into cells more. And there is a story about that as well you could look up. It's quite interesting to see how microscopes developed over time. So thanks for that. Thanks for listening, and I hope that gives you a little understanding of microscopes that you probably didn't have before. Any questions, give us a shout.